So, hi all, I'm Ishani B. And now let's see about data science experiment number 7, that is performance analysis on KNN classification technique. So, the first question is to develop a KNN classification model for the diabetes dataset using the scikit-learn. And here, the first step is to load the dataset and also import the libraries. And inspect the data. For example, show first few lines and column names, data types, number of rows, etc. And second step is to clean the data. Replace zero in specified columns with MAN. So the dataset sometimes uses zero as the placeholder for missing values. So identify the columns with null values and replace. So you know how many missing values need to compute. And the second question is to use the columns pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age as independent variables. So use the feature X as independent variables. Yeah, use the feature X as independent variables. So make sure these columns are numeric. So convert the types if needed. If they're not numeric, you can convert them. So these are clinical predictors commonly used for diabetes prediction. So next one is use target variables as outcome. No, if it is no, it is not diabetic patient, and if it is yes, it is diabetic patient. So if outcome is text, you can give it as no or yes. Or if it is numerical labels, no means 0 and yes is 1. If it is already numeric 0 or 1, you can skip the encoding. So for binary calculation, ensure 1 means positive, that is diabetic, and 0 means negative, that is non-diabetic. So the next one is to divide the data into training, that is 75%, and testing, that is 25%. So split feature X and target Y into training 75% and testing 75%. Use stratified splitting to preserve class proportions in both sets and set a random state. Here the random state is present and it is a fixed state for reproducibility. So the next one is to perform the classification with k is equal to 3. So initiate the k nearest neighbor classifier with k is equal to 3 neighbors. Usually use weights is equal to uniform. And predict the class labels on scaled test set, that is y-pred, and y probability. And f score, we have to predict f score. F score and ROC curve and AUC. So this is the question for these are the steps for question G, sorry H, and so K is equal to 3 ROC curve. This is and this is confusion matrix. So the next one is change the value for of K is in KNN with 5, 7, 9, and 11. So the K values are mentioned here 3, 5, 7, 9, and 11. And we have to plot it. You can give the colors also accuracy and AUC and F1 score. FN score. For 3, we have plotted accuracy is represented by blue color. AUC is represented by orange. F1 score is represented by green. So the last one is analyze and info for which K value the classification algorithms provides better performance. So for this, looking at the trends according to the performance priorities, if minimizing false negatives, it is top priority. Prioritize high recall even at some cost to precision or specify. If you want a balanced, if you want a balanced classifier, prefer the highest F1 or AUC, and that's it.